Time for questions 7 and 8. So once again, I hope that you have tried 7 and 8 already. I'm going to walk you through my solutions for them now. Number 7 says, the cost of extracting oil from a well can be modeled by the relation C equals negative 9x squared plus 144x plus 608.50. Now C is the cost per barrel. And here's where it gets a little interesting. X is the number of 1,000 barrels of oil. So if I had X equals 1, that's actually 1,000 barrels. And that's going to be important in interpreting our answer, okay? So up first, what is the initial operating cost if no barrels are produced? So I could put 0 in for X, or I could just remember, I know how to interpret a quadratic relation, and this value right here is my initial value. $608.50. Okay, B, what number of barrels will create the most expense to extract? I'm looking for my maximum. And again, anytime we're asked to find the maximum, you should say, it's time to complete the square. And so that's what I did here. I completed the square by pulling out my A value, 144 divided by negative 9, left negative 16. Negative 16 divided by 2 is negative 8. Squared is 64, so I added 64 and subtracted 64. Negative 9 times negative 64, bumped 576 out of the equation, factored my perfect square, and I'm left with full vertex form. My vertex is at 8 and 1,184.5. So I want to know what number of barrels. That means I need my X value, which is 8. And remember that X is the number of 1,000 barrels. So if X is 8, that means it's actually 8,000 barrels will have the highest cost to extract. And what is that cost? $1,184.50. Question D, calculate the cost per barrel if 4,000 barrels are extracted from the ground. Show your work. Always show your work, guys. So right here, 4,000, well, I need to remember that X is going to equal 4 because it's the number of thousands. So what I did is I subbed 4 in for every X value in my equation, and I found that extracting 4,000 barrels will cost $1,040.50. Press pause if you need a minute. I'm going to go on and explain number 8. A missile is launched upwards. It follows a path given by h equals negative 7t squared plus 210t. H is the height in meters and t is the time in seconds. What is the maximum height that the missile reaches? Okay, I'm looking for a maximum. What am I going to do? I'm going to complete the square. So I pull out my A value of negative 7, and I'm left with t squared minus 30t. Negative 30 divided by 2 gives me negative 15. 15 squared is 225, so I add and then subtract 225. I multiply negative 7 times negative 225 to bump it out of the brackets, and that gives me 1,575. Factor my perfect square, and I'm left with vertex form, and a vertex of 15 and 1,575. All I was asked for is the maximum height, so the maximum height is 1,575 meters. And that is the end of question 8. So that's the end of this video. Press pause if you need more. Otherwise, go on, try 9, 10, and 11. That's the next video.